is just ever so slightly different. Now, when you think of something and you have to measure length, what do you usually use? You use like a tape measure, right? To figure out how far the wall is and to build a 2x4, whatever. Okay? So you have to measure something. Now, when you're on a circle, in order to measure an arc, that's my angle. In order to measure this arc, I'd have to take a tape measure and measure around a curve. Okay? And I really can't measure around a curve. It's like when you take a. Can I steal your cord for a second?
Yeah.
Cool. This works out nicely. So it's a circle. Just squint. Squint. Yeah, there you go. So it's circle-ish, right?
Yeah.
Now, if I was going to take that and I wanted to figure out the arc where my two fingers are connected here, I'd have to take some sort of a tape measure to measure that out. Well, if you took that part and you straightened it, let's just see if I do this, is it going to be longer than this, what it looks like, or shorter? It'll be longer as you basically pull the curve out of it, if that makes sense. You put a curve into something, you get closer. Okay? So what happens here is that you have to figure out how do you work with that distance value. How do you measure something that's curved as opposed to straight? Okay? With a curved ruler, that would be helpful, but we don't have such a thing. Yeah, you could go around all day long with a string and line up exactly, and then take that string to a ruler and figure it out that way. But there's ways to do this relatively simple. Now, when we measure stuff on circles, when you're talking about distance around something, what's the distance around of a circle called? Circumference, good. Now, how do you find circumference? Remember what that formula was? 2 pi r. Right. So circumference was twice 2 pi r. Or we said circumference was pi times diameter. Okay? Those are two ways of writing out how to solve for circumference. It wasn't tough. We thought it's pretty easy to work with. What happens here is that if you think about it, arc length, this distance on the circle, well, isn't it just part of the circumference? Let's say that you had a radius, real easy here. Let's say the radius here is 4. If the radius is 4, what would the circumference of that circle be in terms of pi? 2 times 4 is 8. 8 pi, very good. You guys are quick-witted today. It's that extra day off you had, right? So when you have the full circle being 8 pi to go all the way around, what would half of it be? A semicircle. What would half of the 8 pi be? 4 pi. So 180 degrees would be 4 pi. What would 90 degrees be? 2 pi. So what you're doing is you're taking portions of the circle via the central angle. Okay? So in order to figure out this thing called arc length, it's nothing more than working with the central angle and the circumference. It's really, really easy to do. It just looks weird to start. Read this real quick. So we get this formula called arc length. Yes, ma'am. Either one. 1 pi or pi. It's synonymous. It's like saying 1x or an x. Means the same. And then at 45, so then it would be 22 and a half would be, I'm going for that. 11 and a quarter would be a quarter pi and so on. So this thing called arc length, and this is how it's going to be written. It's going to say, as opposed to the length of AB, it'll say what is the arc length of AB, or it could say what is the length of AB. And the reason that it's going to imply that it's going to be on the curve is because if it was a segment, it would look like this in the diagram. And it would say the bar above it. Does that make sense? There's going to be a couple of different ways this is going to be written. We're not looking for this blue part that I put in there, so I'll get rid of that. It'll say length AB. That just means I'm talking about the arc length. It'll either say arc length or find the length of the arc, or find the arc, or assuming length of AB, and so on. It's going to always equal a real simple formula. Arc length is going to equal the central angle over 360 times the circumference, 2 pi r. It's a portion of the circumference. What's the portion? Whatever the central angle is. You just divide that by 360. And it's just, it really winds up being a matter of substitution. But what's weird about this is that it just takes time for kids to understand how you put it in your calculator. That's kind of what I want to look at a lot today. So let's see here. Arc length is angle over 360 times 2 pi r. Another name for 2 pi r is pi times diameter or circumference. So I can write this in 3 different ways. Times the circumference. And the reason I like to write these out is because depending upon each problem, you could be given different information. And it's really not that difficult to work with. It really isn't. So if I'm using that example that I have up there already with that radius of 4, let's say I have a central angle of 110. Let's say this is 110. That just means, quite literally, we're substituting all the values we know. The arc length then would be 110 over 360 times 2 times 4 times Now, for those of you guys that have that multi-view calculator, you use the fraction bar, type it all the way through. Because we're going to leave our answers in terms of pi. We're going to get that what's called an exact answer. If you don't have the multi-view calculator, what you have to do is just type all that into the calculator like you would normally, get some fraction, and put pi next to it when you're done. And it's quite literally that straightforward. Okay. So as you type this in, you just get used to typing it. Oops, you get answer 22 pi over 9. That's the answer. You don't have that multi-view calculator, and you have one of the others. You type everything in like you would normally to get the fraction, and then you put a pi next to it when you're done. Because you'll have pi in your answers here. Super exciting, as you can, I can sense that this is a lot. Let's try another one. That's, I'm out of sync here. Okay. I want to find the length xy. Find the length of xy. When I mean length here, remember I'm talking about what's called arc length. Because there's no bar over it. There's no segment drawn within there. This is literally how much of the curve. How much of the circumference is this? Arc length is nothing more than a ratio of the circumference. Yes, ma'am. And the reason why I write it out is that sometimes you're given diameter, sometimes you're given circumference. Sometimes you have to work back and forth. Eventually, by the end of the day here, because this, as you think about it, you have 1, 2, 3 variables. Arc length, angle, circumference, arc length, angle, diameter. There's always 3 variables here. So depending upon, you could be given 2 of the 3, find the third. So I could give you arc length and angle, find the radius. I can give you circumference and arc length, find the angle. I can give you angle and arc length, find the diameter. So we can manipulate these equations and make it work. That's why I always like to write them out, because it's pretty easy as we get going. We'll do examples of all that stuff here today. Yes, ma'am. Yeah, that's why we write them out that way. Because that way, if you're in this case, like you're given diameter, I wouldn't cut that in half just to multiply it by 2 right away. That's why I'm looking at it. If I know that I have a diameter, let's use this one. So here you're given a diameter at 16. That's why I'm not going to cut 16 in half and use 8 and then put it all together. I mean, you can, but you don't need to. You know what I mean? It's just more work. Work smarter, not harder, right? So here you've got angle over 360, pi times the diameter. Because you've got all that information. What's the angle? 90. Let's quite literally put that in the calculator the way that it looks. If you don't have if yours doesn't simplify with pi, just put pi in at the end. So if you do 90 over 360, hit enter, times 16, you're going to get 4. Put a pi next to it. There's your answer. Like I said, we can make this more difficult if you'd like, but it's pretty straightforward. Try this one. This one you're trying to find this side of it. Find that arc length, one that's kind of dumping. Bless you. What's your central angle on this one? 240. What's your radius? 15. Put it all together. 240 over 360 times 2 times 15 times pi. Simplify it out. Go by 6, so that's going to be 4 and 6. So that's 2/3. So that becomes a 30 and 10. So is it 20 pi? 20 pi. Okay. Pretty easy, I hope. Now, I will say that there are parts that get a little weird. Sometimes you got to work backwards. Actually, you know what? Sometimes you got to work backwards. For example, sorry about the awesome circle here. Sometimes you're going to be given diagrams that look kind of like this. Not as great as my hand drawings, but similar. And they're going to give you, like I was saying, 2 out of the 3 possible variables. You've got arc length, angles, and you could have either radius, circumference, or diameter. So if you're given arc length and an angle, you can find the radius. If you're given arc length and an angle, you can find the circumference. If you're given arc length and an angle, you can find the diameter. If you're given arc length and radius, you can find an angle, arc length, circumference, angle, and so on and so on and so on. what happens here is that you're going to be using your calculators basically just to solve what winds up being a one-step algebra problem. That's really what this stuff does. But you have to know how to use your calculator correctly. Because more often than not, you guys can make a dumb mistake with the pi button. Okay. So in this one here, notice how it says 76 degrees at the central angle, but on the arc it says 7.5. When it has that distance part, it's never going to have degrees on the actual circumference. It'll be written with like centimeters or inches or something like that also. Because distances don't have degrees, they have something linear. Okay? So of those three formulas, which one would you use? The second one, the circumference one. So what I would do is this. I'd write it down. Arc length is angle over 360 times circumference. Well, my arc length in this case is what? And my angle is? And now it's quite literally press a couple buttons on the calculator. How do you undo multiply by 7.5 into 76? Yeah, sorry, I just gave 5s and 6s in the problem. How do you undo multiplying by a fraction? Well, you don't divide by a fraction, you multiply by its reciprocal. Okay? You want to multiply by a reciprocal. So in your calculator, all you have to do is this. What's the reciprocal of 76 over 360? Okay? So you type in 360 over 76 times 7.5, and that gets your answer. Rounded to two decimal places. What's going to happen when we start working backwards with these, you probably won't get clean numbers. It's very rare that you'll get a clean number. More often than not, they're going to be decimals. So that would be what? 35, 53? Not bad. Okay. Why don't I do this? I think finding the radius is the weird one, because be very careful how you write it out. So what I tried to draw here was that I'm looking at that 260-degree angle going around, so it's like a larger than 180-degree angle. So that's why I drew that little arrow. That 260 is my central angle. I also darkened in the larger part of the circumference that we're working with. When you get pictures like this, a lot of times if they're in a textbook, they'll be in different colors, so you'll be able to tell which ones you're looking at. It'll say, find the stuff in blue, whatever. Or even on worksheets, a lot of times it's darkened a little bit better, but it's just kind of hard because I don't have this stuff imported into the smartboard. So you'll have to bear with my chicken scratch. So sorry. Okay. Now, if I want to find the radius, which of the three am I going to work with? Top, middle, or bottom? Top one. So first thing I would do is just write out the formula. It's the easiest way to start these. So I know that my arc length is angle over 360, 2 pi r. Okay. Fill in the blanks of what you know. 38.95 is 260 over 360 times 2 pi times r. What are you trying to solve for? Radius. So when you look at all of that, this is a one-step problem. The only thing that's weird is that you don't have what all of this means right now. You just have it written out long form. So here's what you do. You know that it's that junk times r equals 3895. So how would you solve that? Well, you'd have to divide both sides by all that junk, right? Well, the easiest way to do that is to figure out what all that junk means first. So you go to your calculator. And I'm going to type in my 260 over 360 times 2 pi. And I'm going to hit enter. And I'm going to leave that alone. I'm not going to touch anything else in my calculator. Because now I know that, remember how when we were working with sines and angles and stuff, we would use the answer button from time to time? We would do the exact same thing. Because right now, this is the last thing that I hit enter for, that 13 pi over 9. So in essence, what this is 13 pi over 9 times the radius equals 3895. Which means to undo it, 38.95 divided by my answer. You're going to use your answer button again. It makes your life so much easier. If you don't have this calculator, if it came out with a bunch of decimals because you pressed the pi button, that's fine. The answer button will work exactly the same. It does the same exact thing. And there's your response. There's your radius. It does it for you. It's not that the algebra is difficult here. It's just that the number in front of the variable looks like crap. That's really all it is. It just looks really, really weird because it's got a fraction, it's got a pi button, pi symbol in it. It's just a number. Did you guys get 8.58? Yeah. Do you guys go put that back in your locker? Get a different one? So upset you blamed us. We were so innocent. Do you know how smug she just got from re-saying that too? The smugness level just went to like 12. They're heavy, I know. They would stop making them out of lead. Oh, jeez. All right, you guys try one. Find the radius of that one for me, please. Same deal. Find the radius for that one. Please and thank you. Because 2 days of school is too much for you, right? I mean, I get it. You got to pace yourself because it's too much. Yes, ma'am. Oh, go do it. Get up there. Go. Go. So far away. Guys, poor Maddie's trying to act cool. I didn't say that. Yeah, you are cool. Yeah, you can do it that way. Yep, that's fine. Yeah, what you're doing is you're getting rid of and just setting it up for diameter, so you don't have that one extra here. Exactly. You just have to make sure you're not hitting the wrong buttons along the way. Okay? What'd you do? Radius. She did it right, guys. All you're doing, remember, what you're doing here, guys, you've got your 150 divided by, 150 over the 360 times your 2 pi. Hit enter. And then you take your 10.5 divided by your answer. And there goes your radius. Okay? It's really straightforward. Okay? It's really straightforward. Let me give some problems. Yeah. So, oh, it's still pretty quick though. So on this one here, I want you to do numbers. I think I wrote it down over here. Grab one. 1 through 3, and then I think it was 11 to 21. Shouldn't take very long. Well, we need that. Like I said, you guys all have free reign to punch him whenever you want. I don't care, because if you're punching him, I know you did something wrong. For what? You didn't do anything wrong. You know what? What do you have? You got arc length, you got an angle. So arc length. How do you want to play by
Nice work.